Hello everyone. So today's class we are going to start with a short activity. Here you can see that in total there are 12 matchsticks. So let's try to make square using these matchsticks. So in total 4 matchsticks are required to make one square. Let's make other square too. So for making 2 squares, 8 matchsticks are required. So if in total you have to make 4, 6 or 12 squares, how many matchsticks will be required? Let's see. For making one square, we need 4 into 1 matchstick, which is equals to 4. So for making 2 squares, we need 4 into 2, which is equals to 8 matchsticks. For making 3 squares, we need 4 into 3 matchsticks, which is equals to 12. So for making 4 squares, we need 4 into 4 matchsticks, which is equals to 16, and so on. So now if you have to make n squares, that is you don't know the number of squares to be made, then how many matchsticks will be required? The number of matchsticks required will be 4 into n. So here we get a rule that if we have to make any number of square, we just have to multiply the number of square with 4. Total number of matchsticks required to form n number of squares is equals to 4 into n, which is equals to 4n. So let's consider an example. Perimeter of square is equals to 4 into side. So here for perimeter of square we have taken P, and for side we have taken S. So this is true for all possible values of S. It means that whatever the value of S is, this equation, this formula is true. So let's see how. If we take S is equals to 2, then perimeter will be 4 into 2, which is equals to 8. It is true. Now if we take S is equals to 3, P will be equals to 4 into 3, which is equals to 12 units. So if we take any number, any value of x, the perimeter of a square is true for this formula. So for now we can say that clearly P and S are numbers, as when we have taken out the value of perimeter, when S was 2, P was 8. So you can see that P and S, they both are numbers. In a formula, we use letters to represent numbers. As you know that P and S are actually numbers. But in this formula, have we written the value of P8, the value of S2? No. What we have taken? We have taken it in the terms of letters. We have taken a letter. Such letters are called literal numbers. So the letters which we have used here, that is P, S, these letters are called literal numbers. So the name of a chapter is Algebra. So let's see what is algebra. Algebra is generalized arithmetic. So first let me tell you what is arithmetic. Arithmetic is that branch of mathematics in which we study numbers, that is 1, 0, 1, 2, 3, 4, 5, 6, 7, 8 and all the numbers. and the relations between them, the operations which we use, plus, minus, division, multiplication, all the Bodmer's rules, they all come under arithmetic. But here it is given that algebra is generalized arithmetic. Let me first tell you the meaning of generalized. If I say you, all birds have wings. So this is true for all the birds. It means whatever bird it is, it's a pigeon, it's a crow, it is any bird, they all are having their wings. Even the penguins which cannot fly, they have also the wings. So this is true for all the birds. So we can say that all birds have wings is a general thing. So let's take this in terms of mathematics. If I say that when we add an even number and an odd number, we always get answer as a odd number. Like if I take 2, which is an even number, and if I add 2 with 3, which is an odd number, we will get an answer 5, which is an odd number. You can take any example, like if I take other even number, let's take 4, which is an even number, and other odd number as, like if we take 3. So 4 plus 3 is 7, which is an odd number. So if you add even number and an odd number, you will get the answer as an odd number. So this is true for every number. So this is a general. So it's a generalization which is made. So algebra is a generalized arithmetic. So it's a generalized arithmetic. Here we are using the rules which is true for all the numbers, and here the numbers, in place of numbers we are using letters, and which is known as literal numbers, or we can only say it as literals.